Hello, good evening. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Today, my topic of discussion under Physics Lesson 25 is how do vectors work in two-dimensional space? We have already looked at how vectors work in one-dimensional space, but today we're going to look it into two-dimensional space. So we're going to try to find out velocity, average velocity, and then also we're going to introduce you with projectile motion. Projectile motion is really a important critical component of physics because it has uses in real world. Okay, so projectile, then let me see. This right here is a car. If it's going straight, right, that's one dimensional motion. Now, if you've got a, let's say you have this a ball, pretend like this is a ball. If I toss this ball up in the air, it's going to go like this and then finally drop somewhere. So that's projectile motion. So now let's go ahead and dive in. Let me, before I dive in, let me take a let me do a small recall. So we'll call it trip um, down memory lane. Just kind of introduce you one dimensional. Okay, so one dimensional, when you have just, let's say, this right here is your x-axis. Okay, now on x-axis you have 2 points. You have initial point. Okay, I call it x1. Then you have a final point. I call it x2. All right, and then time it takes from here to here. Let's say this right here is t1 and this is t2 in seconds. So now I ask you, if there is a vehicle moving in this direction and I ask you to find the average velocity between x1 and x2, how would you do that? So basically what you would do is you would say v average, all right, velocity average in x is going to be x2 final point minus x1 initial point divided over time it took for the motor vehicle to go from x1 to x2. So then that would be t2 minus t1. And then I introduced you and I said, instead of saying x2 minus x1, why not just say change in x? Change in x is basically delta x. And I've already explained you this is basically a Greek word, delta, which means change. Delta x over delta t. So this is basically y-axis, you have x-axis. Okay, so this is y, this is x. Okay, let's say you have a curve. I'm going to draw this, do my best to draw a good curve. Let's see, it goes like this, kind of like a parabola shape. Okay, so now I ask you, I want you, let's take this as position P. Okay, what I want you to do is that I want you to break this into x and y component. Okay, because anytime when you have a projectile motion, some motion like this, right, you have an x component, you have a y component. It could be a x component in terms of force, it could be x component in terms of velocity, it could be x and y components in terms of acceleration, magnetic field, electric field, and so forth. So then when I ask you to give me the x component and y component, you will say this right here is the x component. And then you'll say this right here is the y component, right? So this right here is the y component of this point right here, and this is the x component. Okay. Then I ask you to find me a vector. So how do you find vector? What you do is that you draw a point arrow straight from this, from the reference or the origin point, from this right here, and this is my vector. Okay, it's not that straight, but pretend like that it's straight. So I call this vector as resultant. Okay, R, and then I have an arrow on top of it. This is my resultant vector. All right, now let me ask you this. If I ask you, now vector has a magnitude as well as direction. Okay, so let's say if I tell you you're driving 20 miles per hour, right? So 20 is the magnitude, all right, and then it has a direction also, which is indicated by the arrow. So this arrow right here dictates that I'm going from left to right. Okay, vector can be negative also, right? So if I ask you to find the absolute value of this guy right here, of the resultant, so then if you recall from my lecture in algebra, absolute values are indicated like this. Okay, that means I'm basically just finding out the magnitude. I don't care if the vector is negative, if the vector is positive, I'm finding the magnitude, and that is absolute values are always positive. So the way you do it, I'm going to write this down. This is absolute value. These two bars right here indicate absolute value. So then what we have is that we have R, absolute value, is equal to, we take x right here, we do x square plus y square and under the root. Okay, so that's my resultant vector at this position, R vector going in this direction. This is just the magnitude. Okay, so if you recall from my algebra lecture, I said, can you find the absolute value of number 5? Okay, and you said, okay, no problem. Absolute value of 5, you do like this, is 5. Okay, cool, very nice. Then I say, can you find me the absolute value of 2 minus 3? All right, so 2 minus 3 we know is negative 1, but I want the absolute value. So what I do is that I put 2 bars and I say 2 minus 3, and the answer is going to be negative 1 absolute value, which is equal to 1. Because when it comes to absolute value, you're just basically measuring how far away, okay, how far away from the reference point. I don't care if it's negative or positive. I'm just measuring how far are you away from reference point. So let me come back and we're going to continue discussion on two-dimensional position, velocity vector, and so forth, and we'll go from there. Take care of yourself. I'll see you in the next lecture. Don't forget to follow me along. Bye-bye.